Hey, fifth grade, now we are ready for some new words or new terms and definitions. So as you can see, I'm on our terms and definitions page here. I kind of already got a head start because I had some technical difficulties and I already filled in my corresponding angles definition like a goober. So reading it here on the screen, it says angles in the same relative position in similar or congruent figures. So I already wrote that down. It's kind of long. Go ahead and hit pause if it would, if it helps you get all of that written down. And then, assuming you've hit play again, we're going to go ahead and start filling out the example right here. I'm going to move this over here. Now, the example image on the slideshow just shows two triangles, so it's not incredibly helpful. I'm going to show you some things to add to it. So we're going to draw two triangles. We're going to try our best to make them congruent or the same. We'll just pretend we're not going to bust out a protractor yet. So I'm going to label these sides, and I would like you to do the same thing. I could probably make this bigger for this portion. And I'm going to label each of the angles. I'm going to label this A, B, C. And then I'm going to label this one D, E, F. That's an F right there. I'm also going to put a little 90-degree angle symbol there so we know that those are right angles. Okay, so corresponding angles are angles in the same relative position in similar or congruent figures. So if I were to ask you, this is triangle 1 and this is triangle 2. If I were to ask you, in triangle 1, look at angle C. Now in triangle 2, which angle is corresponding to one's C? Hopefully you would say F, right? Because C and F are in the same position. They are the same position. They have the same degrees. Those are corresponding. Just like A and D and B and E. This one's kind of simple because the triangles are facing the same direction or they're in the same orientation. It gets confusing when we take some of these triangles and we start turning them around. Then we kind of have to take a step back and really imagine moving those shapes back around in our head. Okay, so we're going to move on to diagonal, which will go pretty quick. So if you need to hit pause to catch up, go ahead and do that. I'm going to go ahead and hit the next. Oh, no, I'm a goober. We're going to go over more corresponding angles. I'm so silly. These slides really help me out. So corresponding sides are matching sides of two or more shapes. Corresponding angles are matching angles. So this is what I was trying to explain. If you took two of the same triangles, or two of the same figures, and you turned one around, because that's what happened here. These are the same. They've just been turned. If there are colors, it's very helpful because you can see that angle D corresponds with angle A. You can see that angle B corresponds with angle E and angle C with angle F. There's also, every once in a while, sometimes we get lucky, and there's these little dash lines on the sides, and those help us find the corresponding sides. So you can see this little dash line right here is 1. Well, here's 1. So this side and this side correspond, just like this side and this side correspond. So I just think that visual is quite helpful. Now, these are angles, right? And the question is, are these corresponding angles congruent? Are they the same angles? So this one is 155 degrees, and this one is also 155 degrees. Now, they are actually both congruent, even though this arm isn't as long as this arm, because really these lines will just keep going on forever and ever. That's why there's an arrow there. So these are congruent because they are literally the same angle. Awesome. So let's go ahead and move on to diagonal, which is pretty easy. I'm sure you know comparatively speaking. I'm sure you know what a diagonal line is, but mathematically, we call it a line segment, and it connects to a vertex. So a vertex are where you have two lines coming together. So this is a vertex, this is a vertex, this is a vertex, this is a vertex, and this is a vertex. So it's a line segment that connects a vertex to another non-adjacent, which means not next to it, vertex. So if I drew a line from this vertex to this vertex, that would not be a diagonal line, right? So it cannot be next to it. It can't be adjacent. So it has to go diagonally across to another one. So I'm going to start writing this down. Maybe you already have done that. Line segment that connects a vertex to another non-adjacent vertex of a polygon. Oh, I ran out of space, so I went out of the box. The only shape, well, I shouldn't say the only shape because I'm not 100% sure. Probably circles. But like a circle doesn't have a vertex, so it can't really have a diagonal line. And triangles, they don't have a vertex on the opposite side. So you cannot draw a diagonal line from one vertex to another vertex in a triangle. You can with a square, right? Or a rectangle. You can just go boop, 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 and there's your diagonal line. You can with, other ones. I'm just going to go with that because it works for me. In case you need to see this larger, in case you need to see this bigger, I'll go ahead and do that. Ooh, there you go. This is the last slide that we are going to look at on this show right here. So when you are finished with your words, please go ahead and continue with the other Nearpod activities. Thanks, everyone. Bye.